learningspace.com.ng.
Question 1AI. It goes, the equation of damp harmonic oscillations is given by m dot d square s dt squared plus b dot dx dt plus kx is equals to 0, where m is a mass of the oscillating particle, the square x dt squared is the acceleration, the x dt is the velocity, x is the displacement, while b and k are constants. Derive the units of b and k using dimensional analysis. Now, before I go to this question, you should understand one thing, or the fundamental principle of dimension analysis. Dimension analysis entails the use of fundamental quantities and fundamental units to analyze an equation in order to establish the relationship between two or more variables. So we use the dimension analysis. Number one, we use dimensional analysis to establish relationship between two or more variables. We also use dimension analysis to show that a particular given equation is dimensionally correct, and the condition for an equation to be dimensionally correct is that it must be homogeneous. What do we mean by it is homogeneous? The components of the equation must have the same units. Then thirdly, dimension analysis is used in the conversion of one system of units to another for various physical quantities. Now let's get down to business. Let's get to the question. Now, in the question, you were given that m dot d square x dt squared plus k dot dx dt plus bx is equals to 0. This is one of the applications of dimension analysis to convert a system of units to another. Now, we are told to use dimension analysis to derive the units of these constants b and constant k. Okay, now if this equation is dimensionally correct, it means that it must be homogeneous. If it is homogeneous, it means that the unit or the dimension of this component here must be the same as the dimension of the component here, and it must also be the same as the dimension of the component here. Okay, now looking at this component, you will see that what you were given is mass and the square x dt squared. Now, the square x dt squared simply represents acceleration. Now, m dot d square x dt squared simply means mass times acceleration. This is force. It means that the units of the component here, which is the dimension for force or unit of force, must have the same unit with this and must have the same unit with this third one here if it is dimensionally correct. Now, what is the dimension for force? We have mass, which is measured in kilogram, and we have acceleration, which is measured in meter per second square. Now, the dimension for mass measured in kilogram is capital letter M. The dimension for distance that is measured in meter is L. And the dimension for time measured in seconds is T. But as you can see here, the power is raised to power minus 2. So it means that the dimension for force is mLT minus 2. Now, for this particular given equation, It means that the dimension of this component here is MLT minus 2. If it is dimensionally correct, this must have the same dimension, MLT minus 2. Likewise, the third one here too must also be MLT minus 2. Now, using this analysis, it is easy for us to determine the dimension of B and dimension of K. If we can determine the dimension of B and K, then we can state the units of B and K. Now, we know that the X, the T, is rate of change of displacement per unit time, and that represents velocity. Our velocity is measured in meter per seconds. Now, and what is that unit? It means that the dimension for this is meter, which is L, time, which is seconds, T, it's raised to power minus 1. Okay, so if we go to this component here, it means our B dot dx dt has this dimension MLT minus 2. And what is multiplying this, our B here, is velocity, having the dimension as shown here, LT minus 1. Okay, so this will give us MLT minus 2. Now, from here, we can get the dimension for B. The dimension for B is going to be MLT minus 2 divided by LT minus 1. Now, applying the principle of indices, we have B equals M L raised to power 0 T raised to power minus 1. If we apply the principle of indices, so from here we can determine the units of this constant B. So what is the unit of constant B? M, representing mass, is in kilogram. Our L, which is raised to power 0, anything raised to power 0 is 1, so that one is gone. Then T, which is time, which is measured in seconds, raised to power minus 1. So hence our B is kilogram per seconds. Now let's get down to the dimension for what? For our K. Now in this particular part here, our Kx, we also said it is said to have the same dimension with the remaining two here, which is MLT minus 2. Knowing fully well that our X is displacement, so our K will be, the dimension for displacement is L, will give you this, MLT minus 2. So our K is going to give you MLT minus 2 divided by L. Okay, now applying the principle of indices, the dimension for K is going to be M L raised to power 0 T minus 2. So from here, from the dimension analysis, we can deduce the units of what? Of K. So the unit for our K is going to be M, which is mass in kilogram. For length, it is no longer there because anything raised to power 0 is 1. Then time is measured in seconds. The power here is minus 2. So with this, our dimension analysis will enable us to obtain the units of the constants that you are given in the equation. Let's get to question 1a. This states that, as you can see in the question, we have show that the expression v squared is equals to v naught squared plus 2as is dimensionally correct, where v and v naught represent final and initial velocity, a is the acceleration, and s is the displacement. Like I told you earlier, that one of the uses of dimension analysis is to show that an equation is dimensionally correct. As you are given in the equation, you are given v squared is equals to v naught squared plus 2as. Now, if this equation is dimensionally correct, it means that the dimension for v squared will be same thing as the dimension for v naught squared, and it is the same thing as the dimension for 2as. Now, we know that the dimension for v will still be the same thing as the dimension of v naught, since both of them represent velocity. And what is velocity? Velocity is displacement per unit time. Now, our displacement is measured in meter, it's L, and the dimension for time is capital letter T. If we compress this, we have V has this dimension L T minus 1. Now, you can see that in this equation, we have a V squared, which is going to be L T minus 1 all squared. So, we have the dimension for V squared to be L squared T minus 2. Okay, now same goes for V naught squared. So what we are left to prove that has the same dimension with this is the 2as. Now, what is our 2as? As we know, 2 is just a number, and it is dimensionless. So since it is dimensionless, since we are measuring this in terms of L and T, it means that this has m raised to power 0, L raised to power 0, T raised to power 0. That's the dimension for 2, since it is dimensionless. Then the dimension for acceleration, we all know that our acceleration is measured in meter per second square. Meter, which represent length, the dimension is L. Seconds, which represent time, the dimension is T. And it has power of minus 2 here. So the dimension for acceleration is LT minus 2. So for this A here, we are going to write LT minus 2. Now the third one here, which is our S, representing displacement, is measuring length. So the dimension for S, which is displacement, is L. Now we know that anything raised to power 0 is 1, so we could ignore this. That's gone. So what's the dimension for our 2as? It's going to be this L multiplied by this L squared, and our T minus 2 out there. So you can see that since our V squared having this dimension L squared T minus 2 is having the same dimension as V naught squared, which is L squared T minus 2, and it's still having the same dimension as 2as, which is L squared T minus 2. Therefore, the equation is dimensionally correct. You can write that in words while you are answering the question in exam. So we will move to question 1B as given in the question. Question 1BI states that the period T of a bubble created by a small charge underwater explosion depends on the blast energy. So we have the period T depends on the blast energy, E, the water pressure, P, and water density, rho. They said you should show by dimension analysis the relationship between the period T, which depends on the pressure P of the water, the relationship between the period T, which depends on the blast energy E, and the relationship between the period T, which depends on the density of the water. Show by dimension analysis the relationship between these three. Now, in dimensional, like I told you earlier, that we usually use dimension analysis to establish the relationship between variables, between various physical quantities. Now, we were told that these depend on the pressure, but we don't know the power of this pressure. It depends on blast energy E. We don't know the power of the blast energy. Let's call it Y. Then let's call the power of the density Z. So if I combine these three, I am going to have the period T depends on the pressure raised to power X, the blast energy raised to power Y, the density of the water raised to power Z. If I decide to introduce a proportionality constant, we are going to have T is equals to K dot P raised to power X, blast energy E raised to power Y, and density of the water rho raised to power Z. Okay, we were told that this period depends on these three. We weren't told that this period depends on the proportionality constant K. We have to introduce this in order to remove this proportion that proportionality sign here. So we are going to assume that this K is dimensionless. So if it is dimensionless, it means that the dimension is going to be m raised to power 0, L raised to power 0, T raised to power 0. The dimension for pressure. Now, what is the dimension for pressure? Now, pressure, as we know in physics, is force per unit area. Okay, now, what is the dimension for force? As I've stated in the first question, we have the dimension for force is m L T minus 2. And the dimension for area is L squared. Since area is measured in meter squared, you can deduce the dimension from the unit, and you can also deduce the dimension from the formula. Like generally, area is length times breadth. Length, the dimension for length is L. The dimension for breadth is still measuring distance, is still L. L times L is L squared. So here, if we apply principle of indices, the dimension for pressure is going to be m L minus 1 T minus 2. So we have the dimension for pressure here, m L minus 1 T minus 2. Then the blast energy. What is the dimension for the blast energy? Energy, you can deduce the dimension for energy from any formula, because energy can neither be created nor destroyed, but it can be converted from one form to another according to law of conservation of energy or first law of thermodynamics. So that means that if it can be converted from one form to another, we can have energy in form of kinetic energy is equivalent to energy in form of potential energy is equivalent to form of light energy, electrical energy, and so on and so forth. So if I decide to make do with kinetic energy, half mv squared. Like I said earlier, this is number. The ordinary number does not have any dimension, so we can call the dimension m raised to power 0, l raised to power 0, and t raised to power 0. M represents the mass, so the dimension for mass is capital letter M, and the dimension for velocity is lt minus 1. So squaring this velocity, we will have square here. So this one automatically is gone, is dimensionless. So this is m dot l raised to power 2 t raised to power minus 2 if we open this bracket with this power. So the dimension for a blast energy here is m l squared t minus 2. As we all know that density of any substance is mass per unit volume, the dimension for mass is L. Volume, the dimension for mass is capital letter M, and the dimension for volume is L cube. How do we get L cube? Generally, volume is length times breadth times height, isn't it? Now, so length is, the dimension is L, breadth, the dimension is L, height, the dimension is still L. So L times L times L is going to give you what? L cube. So the dimension for volume is L cube. So the dimension for density is going to be m L raised to power minus 3. So here we have m L minus 3. Now let's now incorporate all this and form a particular equation. So what do we have here? Now I can rewrite the dimension for period t as m raised to power 0, l raised to power 0, then t raised to power 1 is equals to, k is dimensionless, so the dimension is m raised to power 0, l raised to power 0, t raised to power 0. So our pressure has this dimension m L minus 1 t minus 2, but we don't know the power. It is raised to power x. We also have that our blast energy has this dimension m L squared t minus 2, but in this case we don't know the power. We call the power y. Then we also have that the density has a dimension m L minus 3, but we don't know the power. We call the power z. Okay, now if we try to simplify everything we have here, we have m raised to power 0, l raised to power 0, t raised to power 1. Okay, now this is gone here because ml raised to power 0, m raised to power 0, l raised to power 0, t raised to power 0, everything will give you 1, so we can ignore that. Then we have this mass. If we open the bracket here, we are going to have m raised to power x, l raised to power minus x, t raised to power minus 2x. Then here we have m raised to power y, l raised to power 2y, t raised to power minus 2y. Then we have in the third part, we have our m raised to power z and our l raised to power minus 3z. Okay, now if we try to simplify all this, we collect like terms. So we have l raised to m raised to power 0, l raised to power 0, t raised to power 1 is equals to m raised to power x, l raised to the second m here, we have dot m raised to power y. Then the third one, we have m raised to power z. For L, we have L raised to power minus x dot L raised to power 2y. Then the third L raised to power minus 3z. If we go to our t, we have a t raised to power minus 2x dot t raised to power minus 2y. Okay, so we will now simplify the entire expression using this principle of indices, knowing fully well that a raised to power m times a raised to power n is equals to a raised to power m plus n. So we will be applying this in this part here, where we have m raised to power x, m raised to power y, m raised to power z. So since they are multiplying, the power will be added. The power of this two will be added to compress it to 1. The power of this one too will be added. Simplifying the expressions that we are given earlier, we have m raised to power 0, l raised to power 0, t raised to power 1 to be equals m raised to power x plus y plus z, l raised to power minus x plus 2y minus 3z dot t raised to power minus 2x minus 2y. Now we can now equate the powers. Now let's start with, for t, we have a t raised to power 1 to be equals to t raised to power minus 2x minus 2y. Now we can cancel the base and equate the power. So if we are equating the power, what do we have? We have 1 is equals to minus 2x minus 2y. Now we can collect like terms here. We have our minus 2 into bracket x plus y. So from here, we know that our x plus y is equals to minus 1 all over 2. This is a trivial thing here. Now for m, for our m on this side, it is m raised to power 0. But m on this side is m raised to power x plus y plus z, right? Okay, we can cancel the base and equate the power. So we will have 0 is equals to x plus y plus z. Now let's call this one equation 1. Let's call this one equation 2. You can see that from the equation 1, x plus y is equals to minus half. So you can substitute equation 1 in equation 2. Substituting equation 1 in 2, we are going to have x plus y plus z, which is equals to 0. So our x plus y is minus half plus z equals 0. So it means our z is equals to 1 all over 2. That will allow us to get our z. Then we can now go for our L. Now for L, the power of L on this side is L raised to power 0. And the power of L at this side is L raised to power minus x plus 2y minus 3z. You can cancel the base and equate the power. So if we equate the power, we're going to have 0 is equals to minus x plus 2y minus 3z. Now we can see that from the first, from here we have that our z, we can call this one equation 3. We have that our z is half. Okay, now we can introduce the half from equation 1. We have that our x plus y is equals to half, so our y can be equals to half minus x. So we can call this man equation 4. So we can substitute equation 4 in we can substitute equation 4, yes, in 3, and we can also substitute z equals half in equation 3. So if we substitute equation 4 in 3, this is what we are going to have. We have minus x plus 2y minus 3z is equals to 0. So our minus x plus 2, our y is half minus x. Okay, then minus 3z, which is equals to 1 all over 2. Everything is equals to 0. If we open this bracket, we have a minus x plus 1 minus 2x minus 3 all over 2 is equals to 0. Now, if we collect like terms, minus x is going to give you minus x minus 2x is that's minus 3x plus 1 minus 3 all over 2 is equals to 0. 1 minus 3 all over 2 is just like 1 minus 1.5. That's going to give us minus half. So minus 3x is minus 1 minus half is equals to 0. So we have a minus 3x to be equals to 1 all over 2. If we make x subject of the formula here, our x is going to be minus 1 all over 6. With that, we have obtained the value of x, and we have also obtained the value of z. The value of z here gives us half. The value of x here minus 1 all over 6. So we can also obtain the value of y from equation 4. From equation 4, we have our y to be equals to half minus x. So if you substitute the x value here, we have half minus 1 all over 6. So we have y is equals to half plus 1 all over 6. The LCM is 6. How many till we get in 6? That is 3. 3 times 1, 3. How many 6 we get in 6? 1. 1 times 1, 1. So your y is equals to 4 all over 6. 2 in 4, 2. 2 in 6, 3. So your y invariably is 2 all over 3. Since we have obtained the value of x, y, and z, now we can establish the relationship between the period of the oscillation of the bubble as a result of blast energy that occurs underwater and the density, the blast energy, and the pressure. Okay, now let's write the final relationship. Since we have obtained the value of our x to be minus 1 all over 6, the value of our y to be equals to 2 all over 3, and the value of our z to be equals to 1 all over 2. And we know that the blast energy, the period equals k dot p raised to power x dot the blast energy raised to power y dot density raised to power z. Knowing fully well that this proportionality constant is dimensionless, so we can ignore it. So therefore we can have a t to be equals to, let's just leave it, let's leave it there. We have a p raised to power x, that's minus 1 all over 6, dot our blast energy E raised to power y, which is 2 all over 3, dot our density rho raised to power z, that's 1 all over 2. So if we like, we can decide to simplify further by having e raised to power k dot e raised to power 2 over 3 rho raised to power 1 all over 2, all divided by pressure raised to power 1 all over 6. Now we can bring out 6 here, 1 all over 6 from this equation. So if we bring out 1 all over 6 in this equation, we are going to have e raised to power 4 here dot density raised to power 3, all divided by pressure, everything raised to power 1 all over 6. It's a matter of choice for you to simplify to this level. Once you get to this point, you have established the relationship between the period, the water pressure, the blast energy E, and the density. So that is how we use dimension analysis to establish a relationship between various physical quantities. Let's now move ahead to question 1b. II. Question 1b II, as you can see on the board, it says that a projectile was launched at an angle 60 degrees to the vertical from the top of a cliff 120 meter high with initial velocity of 50 meter per second. Now this question says calculate, that's question alpha, the time of flight, then question beta, its velocity at impact on the ground. Now before I go into this question, you should understand the fundamental principles that is underlying the calculations in projectile. Projectile motion is the motion of an object that is projected through air at a particular angle. The angle might be angle 90 degrees, it can be angle 0 degrees, it can be angle between 90 and 0 degrees, it can be anything. Now in the projectile motion, in the calculations, we have three major cases, as you can see on the screen. We have the case 1, we have case 2, we have case 3. The case 1 is a first case of an object that is launched from a particular platform or a particular horizontal level at a particular angle theta to the horizontal. It moves through air and it lands on the same platform. You can see the formula. You're required to find the height at a particular instant, the time of flight, the velocity at any instant, the range, and the likes. In the second case, you can see case 2 is when an object is launched horizontally from a particular height. You can also apply that, let's say, in a fighter jet that is moving in a straight line, then it now drop bomb. The bomb is going to follow the trajectory in that direction as shown in the diagram that you can see on the screen. So you can see the formulae to find various parameters under that case 2. Case 3, which is the one that the question I want to solve entails, is when an object is launched from a height at a particular angle, then it moves through air and it lands on the ground. So you will see the formula for time of flight there: velocity at impact, velocity at any instant, the range, and the likes. Okay, now you will have to go through that when you are doing your personal studies. Let's get down to business in the question. Now, in the question, you are given a projectile is launched at an angle 60 degrees to the vertical from the top of a cliff. Let's assume that this is the cliff. Now, we now launch a projectile. This is the projectile at an angle 60 degrees to the vertical. Remember, they didn't tell you the angle to the horizontal. They mentioned the angle with which it was projected is to the vertical, 60 degrees. And what we use in the projectile motion formula is angle to the horizontal, which is theta. So we launch this projectile and it lands on the ground with initial velocity u. The initial velocity of 50 meters per second. This angle here, since you know that this is going to make 90 degrees, will give us what? Theta will be equal to 30 degrees. The question says you should calculate the time of flight, whereas you are given the height of this cliff. Let's call the height h. The time it takes to land on the ground from the point of projection to the time it lands on the ground, let's call it capital letter T. Now, in this question, alpha, you use this formula minus h. Note that minus sign is not just there by coincidence. That's derivation for that. Is equals to ut sine theta minus half gt squared. With this formula, this question is over. Okay, now you have been given the height of the cliff to be 120 meter, and you are given theta angle to be 30 degrees. Though the question give you angle to the vertical, you will find the angle to the horizontal by yourself. And you have been given g in the question to be 10 meter per second squared. So you have been given the initial velocity u, which is 50 meters per second. What is left for you to calculate now is the time. Now let's get down to business. We have 1 minus 120 is equals to our u, which is 50 t sine 30 degrees minus half times g, which is 10 t squared. Okay, sine 30, as we know, is half. Half times 50 is 25. So here we are going to have minus 120 is equals to 25t minus half times 10, that is 5t squared. So this expression, we can decide to divide all through by 5. If we divide all through by 5 in order to simplify this expression, we have 120 divided by 5, and 120 divided by 5, we are going to have this 24 is equals to 25 divided by 5 is going to give us 5t minus Then how many 5? 5 and 5 will give you 1 t squared, which is t squared. So you can see that these already give us something in form of quadratic equation. We can transfer everything on this side to this side. We are going to have a t squared minus 5t minus 24 is equals to 0. Now, if you want to solve this quadratic equation, based on your knowledge of quadratic equation, the coefficient of this t squared is 1. This constant is minus 24. You multiply that 1 by minus 24. It's still going to give you minus 24. So you find two numbers that you're going to multiply that will give you minus 24, and you are going to add or subtract is going to give you minus 5. Definitely, we know that that is minus 3. Minus 8 and plus 3. Minus 8 plus 3 is going to give us minus 5. But minus 8 times 3 is going to give us minus 24. So the solution to this is t minus 8 t plus 3 is equals to 0. Now if we solve this, our t minus 8 is going to be 0, and our t plus 3 is also going to be 0. So here our t is going to be 8, or t is going to be minus 3. Since time cannot be negative, so therefore our time of flight that we are looking for is 8 seconds. That answers the first question. Now the second question says that you should calculate the velocity at impact. Now if you want to determine the velocity at impact, you have to determine the horizontal component of the velocity at impact and the vertical component of the velocity Vy at impact. Then that will enable you to calculate the velocity Vi at impact. Now in this beta section, the velocity at impact is square root of Vx squared plus Vy squared. So what is our Vx? We can obtain our Vx from here. We have Vx that is equals to Ux plus 2As. Now horizontal motion is assumed that it is not affected by g, so our g will be 0 here. Then the distance, horizontal distance covered, let's call it x. So this side is gone. So we have our Vx to be the same thing as Ux, which is horizontal component of this velocity when it is resolved horizontally. And resolving this velocity horizontally, we are going to have u cos theta. So, but what about our vertical component of the velocity at impact? We will be needing the maximum height attained above the ground in order to determine that. And for us to obtain the maximum height attained above the ground, we will be needing the maximum height above point of projection, which is y. So this h is equals to our y plus the height of the cliff itself. Now, from our knowledge of case 1 of the projectile, we know that the height, maximum height above point of projection is u squared sine squared theta, all divided by 2g plus h. Okay, now we can evaluate that from our given parameters. Now, so we are going to have our maximum height above the ground to be 50 squared sine squared 30 all divided by 2 times 10 plus 120. The entire value here is going to give us 31.25 plus 120. So if we add this to our age, we are going to have 151.25. Now for the vertical component of the velocity, Vy squared is equals to Uy squared plus 2gh. Now our Vy squared for the vertical component of the velocity, the initial velocity will be 0 for vertical component, but for horizontal component there will be a specific value times 2 times 10 times the maximum height attained above the ground, which is 151.25. So invariably our Vy squared is going to be 3025. Okay, now we can substitute this in the formula for velocity at impact, which is Vx squared, that is u cos theta or squared, plus 2gh, which is our Vy squared. By the time this is 0, so this is going to go off, so our Vy squared is basically 2gh. So the velocity at impact is simply 50 cos 30 degrees all squared plus 2gh, which is 3025. So our 50 cos 30 is, by the time we square our answer, we are going to have 1875 plus 3025. So evaluating this 1875 plus 3025, we are going to have 4900. Square root of 4900 makes the velocity at impact to be 70 meters per second. So that take care of question 1B II. So we will move to the next question. Thank you.